Hello, welcome you all. So last class we have discussed about example 8.1 and 8.2 in chapter 8 motion in CBSE class 9. So today's class we are going to discuss about example 8.3. So we move on to the question. Usha swims in a 90-meter long pool. She continues 180 meter in 1 minute by swimming from one end to the other end and back along the same straight path. Find the average speed and average velocity of Usha. So in this question, we are asking about the average speed and average velocity. Okay. So what is the formula for average speed? Average speed is equal to total distance traveled by total time taken. Average velocity is equal to displacement by time taken. Okay. So we are going to discuss about this some in detail. So what is the total distance covered by Usha? So it's 180 meter. Okay. So I think it's given 180 meter. Okay. And then, so we need to convert into average, we need to find the value of average speed here. So total distance covered by Usha is 180 meter, it's given. So total time taken for complete the swimming pool is 1 minute. So for 1 minute, so we know that we need to convert into seconds. So it is 60 seconds. So 180 divided by 60. So it is 3 meter per second. So if we cancel this term, so you'll get 3 here. So 3 meter per second. So what is the second question they ask? Find the average velocity of Usha. So average velocity is equal to the displacement by total time taken. So to find the displacement, so displacement is initial velocity minus final velocity. So read the question once again. So she covers 180 meter in 1 minute by swimming from one end to the other end. So it's a 90 meter long pool only. So in that given the swimming pool is only 90 meter long. So but Usha swims from one end to another end. So suppose so this is 90 meter. So again she comes back to the end. So if coming from the starting position is called as displacement. So the value would be 0. So 0 divided by 60 second is 0 meter per second. So then we are moving on to example 8.4. So starting from a stationary position. So stationary position is the rest position. So not doing any kind of thing. Rahul pedals his bicycle to attain of velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Okay. So we are going to discuss. So what are the data has been given in this question? So Rahul pedals bicycle to attain the velocity. So initial velocity would be 0. So how we are saying it's 0? So because it is a stationary position. So it is in rest position. So at the rest, u equal to 0. So that's why initial velocity is equal to 0. And final velocity is equal to 6 meter per second. So we know the formula for acceleration. What is the formula for acceleration? Acceleration is equal to v minus u by t. So in the first video, so if you go back and see, there would be a formula session has been discussed here. So in that, a is equal to v minus u by t. So v is final velocity. So it's given is 6 meter per second. U is 0. So because it is a rest position, so it is 0. 6 minus 0. The time is given as 30 seconds. Okay. So please see it 30 seconds. So 6 minus 0 by 30. So it is 6 by 30. So if you cancel it by 6 table, so we are getting the value 5. So 1 by 5 can be written as 0.2 meter per second. How we are writing meter per second here? So because is v minus u, it is given in meter. Okay. So velocity is meter per second. The time is meter per second. So I think it is meter per second square due to writing mistake. Okay. So please correct it. A is equal to 0.2 meter per second. So coming to the case 2. So then he applies brakes. Okay. So in that the velocity, initial velocity would be 6 meter per second. So while riding, he applies brakes. So due to some obstacles, he applied brake. The velocity of bicycle comes down. So at the time, the velocity will be comes down to 4 meter per second. In the next 5 seconds, within 5 seconds, the velocity comes down. So calculate the acceleration of bicycle in both the cases. So this would be the second case. Okay. So initial velocity of this bicycle would be 6 meter per second. So let us take it as u. And final velocity be 4 meter per second after applying the brake. So it is taken as v. So it is 4 meter per second. The time would be given as 5 seconds. So you know the formula for acceleration. Acceleration is equal to v minus u by t. So 4 minus 6 by 5. So minus 2 by 5 minus 0.4 meter per second square. Okay, so this is the answer for the second case. So coming to the example 8.5, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and distance traveled by the train for attaining the velocity. Okay, so this question 8.5, example 8.6 and example 8.7 deals with equations of motions. Okay, so what are the formulas or equations of motions? So let's move on to the tab. So the first equation of motion is related with velocity and time relation. It's called first equation of motion. V is equal to U plus AT. And second equation of motion is S equal to UT plus of AT square. It's position and time relation. Third equation of motion is 2AS equal to V square minus U square, position and velocity. Okay. So coming to the question. The train starting from rest. So rest means you know that initial velocity would be equal to 0. So we have to write U equal to 0. So what is the final velocity? So the train is moving. So the velocity it would be 72 km per hour. So our answer is to be in meter per second. But here it is 72 km per hour. Okay. So how to convert kilometer per hour into meter per second? So that would be a formula. The simple formula is 5 by 18. So kilometer per hour to be converted as meter per second. So 72 into 5 by 18 we need to multiply. So one more formula is there. So how to convert? So you know that kilometer, 1 kilometer is equal to 1000 meter. So 1000 we have to multiply. Then you get 72 into 1000 divided by 60 into 60. So like this you are getting. Okay. So if you multiply 72 by 5 by 18, you will get the answer. So that answer is called as acceleration. So time is given as 50 to 5 minutes. So 5 into 60, so 3000 seconds. So 72 kilometer convert. So you need to convert. So if you convert, you get the answer. Okay. So the acceleration formula A is equal to V minus U by T. So initial velocity would be 0. Final velocity is 20. So 20 minus 0 is 20. So 300 is the time. So okay. So 300 seconds. Okay. 5 into 60, 300 seconds. So 20 by 300. So 0 and 0 will cancel. 2 by 30. So if you multiply it, so if you cancel, you get 1 by 15 here. So A is equal to 1 by 15 meter per second square or 0.06 meter per second square. So we need to find the distance traveled by the train. So this is the question given. So from the third equation of motion, so we are getting 2AS equal to V square minus U square. So how we are writing this formula? So that would be a doubt in it. Okay. So because they have given initial velocity, the final velocity, they are asking about to find the distance. Okay. So coming to the formula, so distance is S. So this S is there, this S is there. So but we are going to find here, they have given initial velocity and final velocity there. But they have given acceleration, though our sum is also acceleration, but time is also given. So you need to apply this formula 2AS equal to V square minus U square. So U equal to 0. So because it is rest, V square we need to find. Okay, so V square is already given. So V is equal to 20 meter per second. So A equal to 1 by 5, 1 by 15. So if you substitute in this equation, so 20 square divided by 2 into 1 by 5, 15. So 20 square is 400, 2 by 50. So if this goes up, you will get the answer. Okay. So these are all about the example